This is the high-level panel discussion. And I have prepared some questions. As we don't have much time in our disposal, I have put down only 2 questions. I would like a short answer from all our panelists. And here is the first. Europe is investing heavily in quantum secure communications through SEEWQCI. From your institutional perspective, how critical is quantum infrastructure for safeguarding national security and Europe's digital sovereignty, a big issue it is, in the coming decade? Please. Starting from you? Yeah.
Well, if we look at the geopolitical situation we have, there are many countries working to achieve interesting technology. One of those technologies is the ability to break cryptography, which we all know is mathematical. And if you look at that specific endeavor worldwide, we've got some non-democratic adversaries that are actually investing quite heavily in that domain. And the only true way to fight fire with fire is to develop that same technology to protect our information and communication infrastructure, which is quantum physics based. We use quantum mechanics to actually achieve that. So I believe that for the coming decades, it's crucial to develop this technology because it will be fundamental to the security of our information and communications infrastructures.
Yeah, okay, thank you. Is that all?
Well, I may say that the Dutch Foreign Ministry and the Commission are perfectly aligned on this side, but I would like to add also that we are for sure working on security, but what we are doing now, mastering quantum technologies and investing on it, is not only to protect ourselves, but also to have a proactive role in the further development of the technology. Now, you've seen in the future of SEEWQCI is, of course, protecting information, but along the way we will develop and enable many technologies that will help us unlock applications in the quantum internet. We can connect quantum sensors. We will be able to make quantum computers speak to each other. That's also a very important part of the whole quantum communication infrastructure that we are developing here.
I mean, as it was mentioned, in I don't know, 10, 15 years, the currently used widely asymmetric cryptographic systems will be vulnerable. So the window to invest and have the technology ready is now. So Europe must ensure that we will be able to design, develop, deploy all the required technology and the full spectrum of equipment needed to tackle all these issues. A very crucial point is also our suppliers. We have to know, identify dependencies, and try to limit them down. So it's not only integrating things, but also suppliers is a very crucial element. Last but not least, I think we should start also integrating post-quantum cryptographic frameworks along to QKD, because at the very end the solution will be somehow integrated, and we will use for more sensitive, let's say, communications, QKD, and also PQC. That's all.
Okay, thanks. Mr. Katsianis?
We have to speak about the infrastructure and the coordination perspective. So we have this organization, the SEEWQCI, which is not about just for future-proof security. It's about building something that is sovereign and has to do with the interoperability of all this system. in the European infrastructure. So what is the role of GRNET on all this? The GRNET is already the coordinator of both LASQCI and the SEEWQCI. So for us, the quantum infrastructure is a part of the broader investment, and we try to secure this investment, and not just as a theory, but as a system that really works, and that's why we try to implement more than 16 use cases in the public sector, in health, in critical infrastructure environment. So in that way we can demonstrate this operational feasibility of the system. So the other important issue is the ecosystem dimension. So we try to create an educational and experimental testbed at the same time. So it's the criticality of EuroQCI does not lie only on the protection of against future threats, but it's about to test our technological European capacity on this system, and making a reinforcement in the sovereign digital capability of the Greek and European partners.
Okay. Mr. Zacharakis, your answer, please.
Thank you. Okay, the problem is that quantum computing is approaching, and as all speakers said before, this poses a threat to the current networks we have for secure communications. Quantum QCI, quantum computing, quantum infrastructure, quantum channel infrastructure, is an answer to this problem. Is this the only answer? No, actually not. As the General Secretary said, there have been some advances in post-quantum cryptography, and some countries, like the United States of America, for example, prefer to invest in this technology rather than QCI. Why do they do that? Maybe because there are some problems already known with QCI technology, operational complexity, and some vulnerability issues in authentication procedures. But I think that the main issue here is that the United States believe that they should invest in what they excel. And they excel in the microchip industry, they excel in having very powerful supercomputers, and that is why they invest in this direction. On the other hand, European Union very wisely has decided to invest in QCI infrastructure, and this is very important because this is the way that Europe will ensure digital sovereignty, as explained before. And finally, about investing in digital infrastructure, we should not, in QCI digital infrastructure, we should not forget that many Asian countries, such as China, for example, are also heavily invested in this direction, which is one of the reasons that Europe has to invest as well. Thank you.
Thank you very much, I say it again, because it was closed. So before advancing to the second question, I would like to ask for your questions, the audience, if you have any, after the second round of answers. We'll have a few minutes in our disposal because then we'll have a photo session and coffee break, so we may advance on that. So the second one, as we move from pilot projects to operational quantum communication infrastructures, and with SEEWQCI establishing a corridor between Southeastern and Western Europe, what are the key policy, governance, and interoperability challenges to ensure that integrated terrestrial and satellite quantum networks become trusted? Trust is, and will remain a cornerstone in our lives. For governments, defense, and critical infrastructure by, let's say, 2030. Again.
Is it on?
Yes. Yeah.
Well, first of all, I believe that governments and ministries need to understand the technology itself. Because today, even within this panel, I heard this myth that you either have to choose between quantum key distribution or post-quantum cryptography. Last summer, with our Ministry of Foreign Affairs, together with some different consortium partners, we did a test, and we have shown that both QKD and PQC together are fundamental to achieve information and communication security. It is so that QKD actually operates on a different level than PQC does. And if you combine both in a very smart way, you get a deep security, which actually gives you multiple layers of securing your information and communications infrastructure. So number one is governments and ministries, and maybe even telecom operators, need to invest in knowledge with regards to these technologies. Furthermore, I would advise governments to try and ascertain the worldwide developments of this technology and what the geopolitical motives are behind the different choices that different geopolitical actors make. Because that will give you a completely different view on how the world is actually developing and when these threats will actually be manifest. Because, for example, the Chinese government will have a quantum space-operated, quantum key-distributed network by the end of 2026. So there's a challenge there for Europe. So we need to step up, we need to understand, and we need to be very smart on how we develop these technologies. Thank you.
Yep. For policy, one of the big challenges that we have now in the current phase of the QKD development is to get into the world of cybersecurity. In this world, we have very strict requirements, security requirements based usually on zero trust principles, on crypto agility, and on availability of data. And making this mindset shift is very important for the future deployments of QKD, and that's why maybe we face some resistance from some actors. And these actors, NSAs, they are the entities directly responsible for the protection of their member states' information, and they have a particular interest in choosing the appropriate solutions, whether it's PQC, QKD, a combination. So we really have to keep that in mind, that we are trying to search the best technological solution to this challenge that is presented to us. I also wanted to say that one pressing issue is to work on standardization of QKD systems. Unfortunately, as it said, in this world, standardization comes always too late and always too early. This makes it a particularly tricky challenge. You never know when to start, which way to go, but it's the first step to work towards full security certification of QKD products and systems, and that is one of the milestones that we need to achieve to get the support of governments and defense of the ones that still do not trust in these technologies.
Yeah, I will echo most of the points already raised. I mean, moving from pilot demonstrators to operational communication corridors, we need, at the European level, a harmonized, let's say, framework. And standardization is the key thing there. So we should work in this front, trying to have the required frameworks from ETSI, but also, I don't know, from IEEE, or what is the state of the art in protocols. So we should somehow elaborate on those. So we should have an interoperability among fiber QKD, satellite QKD, the future quantum repeaters. Everything should be working seamlessly. But I will also again mention suppliers, from photon sources to detectors to software, key management systems. We need certificates for the suppliers also. We see now what is happening with the new Cyber Act and the radio in the mobile networks. We are not there, so we need the certification of all the parts of the equipment and the equipment in order to have operational deployments.
So we're talking about the challenges. So we have a project and we have to reply what are the main challenges. So we have a pilot project that try to be an operational project. So we have one challenge is interoperability, the second is the governance of the cross-border implementation, the third one is can we have a smooth convergence of terrestrial fiber and optical ground station with the future satellites. So in this project, we have to ensure, as in the first challenge, the interoperability between vendors, technologies, and architectural matters as well. In the second challenge, we have to connect Greece, Bulgaria in terrestrial matter, and then via satellite we have to be connected via Cyprus and Holland. I don't have any information about the cable for Cyprus, but I don't know. We will discuss it maybe in okay, we can use the space now. So can we have a smooth convergence for the fiber QKD networks and the space future space-based technology? This is what we are trying to answer in this project. And in order to test these facilities, we're going to implement 39, it's the truth, 39 cross-border demonstration across terrestrial, satellite, and hybrid configuration. So, for us, it's too important to be here to justify these challenges. I think that we are here more than 10 representatives here from the SEEWQCI, and we try to enable this trusted, scalable, and operational quantum communication via SEEWQCI.
Thank you. The issue here is to deploy a project that is, let's say, a research project, but actually it will lead to an operational implementation. Several challenges are here. First of all, there have to be some kind of certification and schemes and security assurance frameworks. With the classical IT products, there is the common criteria framework. Something like that has to be established in the near future for QCI technology. Governance issues really is a challenge. For example, within the SEEWQCI project, 35 trusted nodes will be operated. When we're talking about trusted node, there has to be trust. So in order to be trust in this node, there has to be a procedure of governance for nodes across different countries and some kind of auditing mechanism. Certainly, interoperability is another issue, is another challenge, especially between the terrestrial and the satellite links. And I would like to point out what was said before, that the vendors of this equipment, the vendors of all the whole supply chain of this equipment, somehow have to be accredited, and there has to be an accreditation scheme for these vendors, either European or not European ones. Thank you.
Thanks a lot. Thanks a lot. Any questions from the audience? Here we have one. Another one. 2, 3. Okay, please. Yeah. It's the left one.
Okay, my name is Karatzalos. Sorry, my name is Kyriakos Galli. I'm a professor at the Cyprus University of Technology. I listened carefully to the panel. I have this kind of feeling that when we start with Ferdinand, he refers to certain things. And as we move further down the line, so we move from discussions of potential threat, this is my feeling, and then as we move further down the line, we talk about operational suitability, capability control. We seem to be dancing around an issue, one aspect of an issue at least, which is how do we foresee this technology used in the future for protection of Europe from a military perspective? Is this something you're considering? It certainly may be important to us. So I'm just curious to see where you see this technology going beyond the commercial and towards the military applications. Because I think eventually this is where we will get to, right?
I mean, secure communication is for all the applications that a government is handling and all the operations that are deployed. So military and defense is included. I wouldn't, though, put it separately with some more particular specs. If it's secure, the communication is secure. And this is, I mean, for my private data, medical data that I want to send them somewhere. So, I mean, I wouldn't deviate a lot in this. But of course, military is there.
From the Ministry of Foreign Affairs, we actively work together with our Ministry of Defense within the Netherlands. And we believe that both the civil part is very important, because we always talk about critical infrastructures, but imagine that your social system would collapse because it's kidnapped. The first days you won't have a problem, but a couple of weeks later, you're looking at an existential crisis for your country because people will rise up because they cannot buy bread. It's that simple. The other part, if you look at the Ministry of Defense, the actual security of their information and communication is very, very important. And geopolitical, you see multiple conflicts arise throughout the world, sometimes in locations we didn't even expect to have problems. So our collaboration with the Ministry of Defense is to build actually a kind of like suitcase that you can bring along and deploy in any place on the planet to get your information and communication secured. And we believe that that needs to be quantum-based, as all of the other geopolitical actors are actually building systems the same way and are building systems to actually engage classical cryptography. And we believe it will be sooner rather than later. So these two parts are very important. You cannot forget about defense as far as we are concerned.
Hello, my name is Martin Stierle from the Austrian Institute of Technology. Since we have here experts from the Ministry of Telecommunication or Digital Governance, I wanted to bring one aspect further here, which we discuss in Austria with our Chancellery and ministries. That is basically the discussion of total cost of ownership. Because in the end, sometimes if you have public resources, it might be possible to go for two solutions. But in the end, you will have with the CISO of a company the discussion on costs. And there is at least one aspect which is really relevant. Coming, and I formerly worked with the incumbent in Austria, with the telecom operator, coming from the incumbents and the opening up of the telecom market and the universal service definitions, basically, telecom operators are not in position to sell fibers. So they only ask to, you are allowed to lease fiber, but we will not sell a fiber, not even to the government. Even if the government owns a bit of the telecom operator. And the total cost of ownership, the fiber costs are more than the KETYAK costs, of course, yeah? In total cost of ownership. It might be a bit different if we have full cost of trusted nodes, for however we decide what that is and how it is protected. But in principle, if you go for a link-to-link or direct link connection, the lease of fiber, if you're not directly in the downtown, but connecting different towns, normally that's higher than the cost of the KETYAK infrastructure itself and the key management and whatever you need there. Is there any discussions at the European level that one is changing this universal service, the definition in Europe, at least for the governmental networks defended by KETYAK?
Yeah, this is a more general question. Probably the General Secretary or Mr. Zacharakis could comment on this. We know, I'm optimistic in general, but I'm sure that this project will do well and we will deliver what the expectations were when the project were designed, right? But in general, in the world scheme, we will face challenges. That is, historically, Europe can innovate, but scientifically, but the commercial exploitation happens across the side of the Atlantic for various reasons. And now, also in the Far East, we have extremely strong competition for commercial products of high quality. So my general question is, even though we do get into this endeavor and we will, using QKD or other technologies that will be developed locally, we will be able to communicate securely. It is typically the commercial market, the other customers that define how technology is developed, because it's a bigger market than the government. So are there any thoughts in European policy how this segment of technology could be supported in a way that Europe will remain relevant in developing and supporting and leading in this type of technologies down the road, because this is the future? Or we will develop something and then some competitors will develop something more efficient, and just because of the fact that we cannot exploit and we cannot sell part of this technology all over the world, we will be left behind. How can we learn from the past, in a sense?
Yeah, I can elaborate a lot on this. I don't know how much time we have. So there is discussion, I mean, during the previous year on competitiveness in general. So even the new commission, I mean, brought it again, and there are a lot of discussions. Now we have Digital Network Act that we start discussing. Actually, today there is a workshop about this in Europe. We have the Single Market Initiative there. And this, I mean, from the one side, there are discussions about consolidation. We have big industries, Leonardo, Airbus, Thales joining. There are discussions about intra-OHB. So there is, from the one side, consolidation, so to have bigger players that can compete in a global scale more efficiently. But I'm not sure we have found the manner of, since I mean, we're investing in this domain, quantum tech, to make European champions that are in a global scale competitive. So this is still something that we should focus on, apart from consolidation. So there is discussion on single market. Now, regarding the previous question, there is again the Digital Network Act that maybe can, there is room for elaboration in these matters, but I think this, I don't know if it should be solved or it finally will be solved at the European level, or each member state should find its own way of having the ownership of the required, at least, infrastructure for all the sensitive matters, which is actually the case in Greece for part of the networks, so from asymmetric to symmetric, but we should see, I mean, in these corridors and networks that we're developing, ownership also. I totally agree.
Thank you. Any other comment on that? No. So, that's it. Thank you very much.